and Department of Civil Engineering, IIT Madras. I welcome all the participants for the national webinar on use of innovative materials for concrete applications. So, on behalf of the ICA Chennai Center, we would like to thank UltraTech Cement Ltd for sponsoring this program. Jagan, can you just play a short video of UltraTech Cement?
The year was 1983. India had made history. It was the time when we as a nation started believing that anything is possible. Around the same time, we took our first step in the transformational journey of India. We laid down the foundation of Rajashri and Vikram Cement Works to help every Indian realize his dream of owning a home. It was with this purpose that we started our journey. In 1988, the Birla White Cement plant was commissioned. In 1998, we built India's first RMC plant to transform the country's landscape at speed. Our common mission brought our cement businesses together in 1998. With the acquisition of L&T Cement, we created our new identity in 2004. In 2010, we acquired Star Cement. To keep pace with the demands of a rapidly growing nation, we expanded our capacity organically and inorganically. Along this journey, we laid down the tracks of progress and built the gateways to a new India. We connected villages to cities and made urban commute faster and safer. From naval bases to world-class ports, and from water reservoirs to stadiums, together we've made it all happen. We've built one of the largest logistics networks in the country and have invested in skill development of masons across India, including women masons. UltraTech's initiative, India Next, was launched 4 years ago to engage with the brightest minds in engineering and architecture community to build a more meaningful future for India. The acquisition of JP Cement units established our presence in Himachal Pradesh, Central India and Coastal Andhra Pradesh, making us the only pan-India cement player and a leader in all zones. We continued our successful organic and inorganic growth with the commissioning of Dhar Cement Works, the acquisition of Benani Cement and the merger of Century Cement. With this, we crossed an important milestone, adding an unprecedented 47 million tons in just 3 years. This addition is more than the capacity of the next largest player in India. Today, we are at the threshold of yet another exciting chapter of our and the nation's growth. Our vision of being the leader in building solutions has driven us to build the India of tomorrow. What started as a single plant 36 years ago has grown into 52 cement plants and 100 plus RMC plants. Today, we've become one of India's most valuable brands with a portfolio of 56 product offerings, catering to 90,000 plus channel partners across the country. The trust that you have reposed in us has helped us reach the spectacular milestone of 100 million tons plus capacity in 2019. We continue to anticipate our customers' changing needs and provide innovative products and solutions, because we believe that whether you are building your home or an iconic infrastructure, it is not just a structure but your badge of reputation, and hence you would want only the best. India's #1 cement, UltraTech, is always with you on the path of progress.
So with this short introduction about the UltraTech Cement, we'll just move to the program. So today we have the program on national webinar on use of innovative materials for concrete applications. So before going for the program, most of you would have known about the Indian Concrete Institute. We will be just giving a small introduction about the ICA. So ICA is one of the leading professional associations in India and caters to the professional needs of the individuals and organizations involved in the concrete construction industry. It is totally a non-profit organization and it is dedicated to disseminate the knowledge on science and technology to concrete, to promote concrete construction, and to address the educational and research needs in this area. The genesis of ICA dates back to the year 1982, when SCRC, Chennai, and Anna University jointly conducted an international seminar on modern concrete construction practices. The overwhelming response to the seminar prompted the organizers to establish ICA with around 500 members from 5 regional centers, including the Chennai center. Since then, there's no looking back, and ICA has grown in leaps and bounds. And today we have 800 plus individual life members and 60 plus organization members. I request all the participants, if you're not a member of ICA, you can become a member of ICA by logging into www.indianconcreteinstitute.org or www.icachennai.org, or subsequently you can mail to icachennai@gmail.com. So with this short introduction ICA, we can go to the program on innovative materials for concrete applications. So as part of the major objective is, we don't want to have a single speaker to concentrate the program. Instead, we can have 3 or 4 speakers who can share their experiences on the innovative materials. In this part, in the morning section, we have 3 speakers from academic parts. One is Dr. Surender Singh, Assistant Professor from IIT Madras, and then Ram VG and Rohit Prajapati from IIT Madras, both the doctoral scholars. Along with that, we have our most experienced person, Dr. Manamohan Kalgal from UltraTech Cement, who will be giving expertise on aggregation concrete need for sustainable approach. The first session will be by Dr. Surender Singh. Just a small introduction about Surender Singh. He is an assistant professor in the Department of Civil Engineering, IIT Madras. He has completed his PhD at IIT Roorkee in 2018, where he worked on the recycled materials for cement concrete pavement applications. He holds 2 national awards for his work on concrete pavements, namely the Indian National Academy of Engineering Innovative Project Award in 2019 and Indian Road Congress Award in 2017. Presently, Surender is extensively working on different aspects of concrete pavements, such as valorization of recycled materials, pavement material characterization, design, monitoring and rehabilitation of concrete pavements, roller compacted concrete and rural roads, etc. In total, he has published more than 30 dedicated scientific articles on sustainable cement concrete mixes in various international science citation index journals. Besides, he is a guest associate for the International Journal of Frontiers in Built Environment and a reviewer for many international SCA journals. He is also holding other prestigious positions as well as Vice Chairperson of RILEM's first ever Youth Council, an executive committee member of ICA Chennai Center, and an academic committee member for Kurukshetra University. In his leisure time, he used to play cricket, chess, and watching documentary movies. Today, he along with his IIT Madras team, will be sharing their experience on the effective use and management of construction and demolition waste for sustainable concrete mixes. With this short introduction, I will request Dr. Surender Singh to start his presentation. Thank you, sir.
Thank you, Dr. Kalgal, for the introduction. I'll share my screen. Yeah, I hope it is visible to everyone.
Yes, sir.
Yeah, thank you, Dr. Kalgal, once again. So actually, before starting the presentation, I would like to discuss something about the how we come up with this webinar series. This time we thought we'll be having one presentation in every month, and there will be it's not only one speaker who will be sharing his or her experience. We'll be having combination, mostly some people who are doing the fundamental work, and from the industry side who are doing the application oriented work. So I urge all the participants to register for different presentation, because here we'll not be showing our laboratory results, but the experiences that we have gained after thoroughly talking to various stockholders. For example, for this presentation, that is the state of the art on C&D waste recycling, we met with different stakeholders, such as the crusher owners, the persons who are constructing the payments or the concrete structures, the persons who are engaged in demolition activities. And after thoroughly discussing with them, we will be sharing our experience. I hope you'll be liking it. So thank you once again, and I hope you all are doing fine in this pandemic. So thank you, Dr. Kannan. So right now I'm starting my sharing my experience. As I mentioned, me and my team will be sharing the experience on the C&D waste recycling in India. So I'll be covering the part.
ஐடி அனுப்புறேன் நீ இப்ப கேக்குறியா வெபினார் போகுது
Can you
Continue, sir. Yes,
Can you
continue,
mute
sir. Okay,
person?
sorry. I'm going to start. Okay.
Okay. Yeah, maybe we can have one person who will be muting the other participants. Okay. So me and my team will be discussing today, or precisely speaking, sharing the experience on various aspects of C&D waste. I'll be taking the work on the parameters and the challenges that we are facing in production and utilization of C&D waste. So the big picture is that we have to think about what will happen in next 10 years. Okay, obviously, as you all must be knowing, India will be the fastest growing construction market in the next 10 years. Maybe we okay. And then by 2030, India will be the third largest construction market, and the urbanization will be reaching to 40%. Right now it's 30%, and in the next 10 years it will be reaching to 40%. And obviously, it is expected that India will be bypassing China in becoming the most populated country. So for accommodating all these persons, okay, we need more houses. Around 170 million additional houses are yet to be constructed by 2030, and more than 5 lakhs kilometer multi-lane highways will be constructed in the next 10 years. Okay, so for all these things, additional houses or multi-lane expressways or the highways, what will be needing? Obviously, we'll be needing the money to construct the houses and connecting the different parts of the country, right? In addition, we'll be needing the resources. So up to now, what we are doing, we are, demolishing the mountains in order to acquire the coarse aggregates, stopping the rivers, and in order to acquire the fine aggregates, or we can say river sand or natural sand, whatever we can call it. And for the furnitures, we can get the furniture from the wood. But it's a past scenario. Obviously, we are doing this thing in the present domain also. But yeah, we should know that how much of the natural reservoirs are available for our use, right? And then how much is our total demand? And if there is a misbalance, then obviously we need to explore for other alternatives. So there are many studies that are available to quantify that how much, what is the mismatch between the demand and the reservoir. Okay, so the river sand or the sand or the fine aggregates, the total demand for annum is 751 million, and mostly you have seen that in most part of the country it is banned. Okay, for specific use we are still doing it, but yeah, in most part of the country it is banned. If I talk about the aggregates, so there are different studies. They are saying that the aggregate demand per annum is around 1.6 billions to 2 billions, and the reservoir available is 126 billion tons. Okay, means there is enough amount of the material that is required. Okay, and then which is available also. Limestone 320 million is required per annum, and 89.3 billion tons is available. But we should remember that these reservoirs, okay, most of the reservoirs right now are in the reserved areas where we cannot do the milling activities, we cannot demolish it, right? For example, national forest, reserve forest, right? Reserve parks where we cannot do the extraction. So that means if we keep the current demand and consumption of the materials constant, in the next 40 to 80 years, we'll be having no resources for our consumption. Okay, so that means it is the right time to explore the other alternative, for civil engineering application, right? So usually there could be three questions in your mind. Okay, the first question will be, can we use C&D waste for the concrete application? Okay, everyone now is thinking how to use the C&D waste. If yes, what fraction we can use. So CNT waste can have different fractions. Coarse aggregate, you can get it from it, fine aggregates, and powder also. When you crush the CNT waste, some powder will be generating. Can we use the powder? So this is the current demand, right? And if you are able to use, how much proportion we can use it? And then, is it a really worried situation in India? How much CNT waste is available in India? We should know it, right? So I hope with today's presentation, we might be able to address all the three questions, right? You all knows, okay, I'll not be covering this part, that CNT waste is the waste material that will be getting after, during the construction, or you're doing some remodeling activities, repair, maintenance, rehabilitation, or the demolition of any structure, whether it's buildings, pavement, and other structures. So recently, some renovation work is going inside the IIT Madras campus, and we took the photos from there. The main purpose to show these pictures is that you might have seen that nearby your areas, many activities are being done, and those activities will be generating the CND waste, right? So normally the normal practice is to dump the CND waste in nearby areas. Okay, but yeah, so what we argue not to dump it, right? We can recycle it. Okay, so if you take some CND waste, let's say a building is being demolished, okay, or a pavement is being repaired or being demolished. So out of all the materials, around 23% of that waste will be comprising of concrete waste. That means only the building waste. And then it could have soil component in it, it could have tiles, glass, or other machinery things like brick beds in it. It can have asphalt in it because if you are removing the asphalt pavement. So in a broader sense, sir, what we mean to say that almost if we did this study, we found that around 20 to 30% of the total CNT waste will be comprising the concrete waste. Okay, so there is a confusion. Like some people I heard that they'll be calling recycle aggregate, some will be calling recycle concrete aggregate. So the major difference between the recycle aggregates and recycle concrete aggregate is the material, right? So if we call as recycle aggregate, it will not be having concrete portion. Okay, it will be having concrete portion, but it will be a mixture. Not only the concrete portion, but it will also having some bricks. It will be having stones in it. It will be having tiles or the mortar in it of a specific size. That means, let here in the picture you can see the CND waste. Okay, so it need to be taken out, crushed in different sizes, and the mixture of that material will be known as recycle aggregate. Okay, we can call them as the process CND waste because we did the resizing. If we talk about the recycled concrete aggregate, it is the same thing, but here what I will be doing, will be taking away only the concrete portion and then resizing it into different fractions. In that scenario, we'll be calling it the RCA or recycled concrete aggregates. Okay, so in today's presentation, I'll be focusing on, or my team will be focusing on recycled concrete aggregates, not the recycle aggregate, right? So, as per the different studies which have been done in India, what we have seen that there is a underestimation of the total CND waste generation. Like in 2001, it was predicted that India is producing 15 million tons of CND waste per annum. In 2015, another study came up. So after 15 years, if it is coming, so it will be, you can assume that it to be, an effective one. So they consider only 9 cities, big cities in India like Mumbai and Delhi. They found that the India is producing around 4.2 million tons of CND waste. And then in 2017, one more study came. It said, no, we are producing only 2.82 million tons, although they have excluded Delhi, and Delhi produces significant amount of CND waste. In 2016, again, one more study came. They used the extrapolation. They found that in the entire India, if we consider the CND waste, around 714 million tons of the CND waste will be produced. In 2018, one more estimation came. This is we are only producing 100 million tons. So there is a clear mismatch. All right. Then on how much of the CND waste in India we are generating. This could be because of the many reasons. Because some of the companies might be dumping the CND waste. Okay, so they go unaccounted. So the experts who are working on the CND waste management, they think that this estimated quantum is highly underestimated. It could be around 1,000 million tons. It could be around 500 million tons also. Okay. So on an average, we can assume that in India, more than 500 million tons of the CND waste is being generated. And if we compare ourselves with the foreign lands, what we can see, if we are considering 530 million tons C&D waste generation. We are standing at the second position after China. Third is the US in the C&D production per annum. Okay, but we know that most of the C&D waste is being dumped here and there. If we account that, if we consider that we are producing more than 1,000 million tons per annum, then we could be at number one, right? So it's not a good thing, right? But on the other hand, it's a good thing if you are able to utilize it. But we have to see how much of the C&D waste that is being generated in India and how much we are utilizing it. So, there are many studies, many government studies has been taking place. Earlier, it was like we are utilizing or recycling only 2% of the C&D waste. But a recent study has shown that we are able to recycle only 1% of the entire C&D waste quantum in India. And if I talk about Japan and the European countries where the quantum on the C&D waste is lesser as compared to India, they are doing 90% recycling. So what are the reasons? Right, we are not able to use the C&D waste. You might have seen many ads, many research publications where they are extensively using the C&D waste. But why not it is happening in the field? What are the main reasons? Right. So we did some survey. We found these are the main reasons. Like somebody says that the cost of the C&D waste will be high. Let's say if we consider the coarse aggregate, the cost will be around 2 rupees. But if you talk about the C&D waste, it could be around 3 rupees also, little bit high, 20% extra cost will be there. But it depends upon the transportation and other reasons. So in some scenarios, I agree with you that the cost could be higher, but in most of the scenarios, it will be either same or it will be lesser. But we have to remember that in the next 40 to 80 years, we'll not be having the natural aggregate. So, and now the technology will be grooming, and then, slowly the rate will be reducing. The other thing what we found that there is a lack of knowledge on the recycled product, but not now. Right now we have the specifications. We have you might have seen in the new parliament also that is being constructed. They are using recycled aggregate, so there is no lack of knowledge. Right? There's some says that there is a limited technologies for the waste recovery, but not now. We have many companies that are coming forward. They say we can recycle any waste that is available. Some might you be thinking that the recycle aggregate quality will be lesser. Okay, there will be many contaminants like soil will be sticking. Yeah, but these could be addressed very easily. We have the readdressal means. And then, yeah, there is a lack of market availability of the product. If let's say if I want to construct my home, I want to utilize this C&D waste. Okay, I'll go to the market. Maybe I'll not be finding the availability of the product, final product. Okay, so yeah, but yeah, nowadays, you can see the crushers agency, they came into the product manufacturing side also. Okay, they are producing different kinds of the product consisting of the C&D waste. And then some says that, in fact, most of the people were saying that we cannot use it because there are no specifications or the standards or the permits, but not now. We have many specifications that came in the recent time, which is allowing you to use the C&D waste. We'll be discussing in the, next slide. But the main reason that we have found is the hesitation amongst contractor and the engineers. They are not ready to use the C&D waste. They'll be thinking that if some bad things will happen, who will be responsible, right? So this is the main reason. So let's say if you are able to recycle the entire C&D waste, how much we can save? So we did the calculation. We found that around 10 to 20% of the natural resources you can save if you are using the C&D waste, right? And remember, this is the underestimation because we don't know the exact quantum of the C&D waste that is generated in India. But the question is how much really of this C&D waste we can reuse it, right? Nowadays, if you see most of the plants, they are selling paver blocks or interlocking blocks we can call for footpaths, for cycle tracks, for sidewalks, for different applications, right? So mostly in India, we are producing the paver blocks made with the recycle aggregate, right? Or maybe the partition wall, they are using it. But the concern is that the quantum of the C&D waste that could be recycled here will be very, very less. We have to think beyond it. We have to see for the structural application whether we can use the C&D waste or not. So right now in India, we are having 13 plants, C&D plants, right, which are crushing. So it started from Delhi, and now in Chennai, we are having 2 plants. So we start communications is, had the standard to work, and soon it will be inaugurated, right? But considering the quantum of the C&D waste and the crushers that are available, there is a huge mismatch. So the ministry came with a proposal that whichever city is having more than 1 million population, they should have at least one recycling plant. So we did the analysis. What we found that considering this ordinance, at least 160 recycling facilities should be available in India. It's minimum 160 recycling facility, and currently we are having only 13 facilities. That means in the nearby time, many more recycling facilities will be coming, and we could see the use of more C&D waste. So as per the specifications are concerned, we have recently seen that IES created, this is the specification and the guidelines for the aggregates to be used for concrete applications. It says that we can use the recycled concrete aggregate up to a percentage of 25% if you're going with the plain concrete. If you want to use, or if you intend to use the recycled aggregate for reinforced concrete, you can use up to 20%. But yeah, because it's a reinforced concrete, there could be some durability or the corrosion related issues. So they restrict it to the application up to M25 grade of the concrete. But if the grade of the concrete is less than M15, for example, ground floor or some footpaths or the base course of the pavement, we can replace up to 100%, right? Whether it's a coarse aggregate or the fine aggregate. So that means now you can easily use it because the code is already specifying it. If I talk about the payment application, for embankment, we can recycle up to 100%. For subgrade, we can use the recycled aggregates up to 100%. For granular subbase, which is used for the separation membrane or the drainage layer, we can use the concrete chunks, that is the recycled concrete aggregate, up to 100%. So for the highway application, we are following the mode specification, and mode specification is the recent one is having a separate section, clause 405, on how to use the crushed cement concrete subbase, crushed concrete for the subbase application. And for the dry-lined concrete, which is used as a subbase course or the upper base course for payment application, we can recycle up to 30%. And sadly, we are not doing so. So that is the reason that we are only recycling 1% of the C&D waste. And if I compare with the other countries, in most of the countries for structural applications, we have seen that the specification is that they're allowing the use of the C&D waste for in the plain concrete up to a proportion of 25% to 30%, right? So what is the reason that we are not able to recycle? We are not recycling. The main reason is the added mortar content. So you can see the natural aggregate will be like that. But in case of the recycled concrete aggregate, it will be having the natural aggregate, definitely, but it will be having a added mortar content, right? Or you can see some two aggregates are sticking with each other. We call them as the agglomerated particles, right? So this is the main reason, the adhered mortar content, okay, mortar from the previous building. So because of this mortar content, what is happening? The physical properties of the recycled aggregate is way lesser than the properties of the natural aggregate. That means the quality of the recycled aggregate, if I talk about the coarser fraction, it is way lesser than the natural aggregates that we are normally using for the structure activities, right? And that is the reason. And why the physical properties are lesser? Because of the presence of the adhered mortar, right? And then if you are using this recycled aggregate in the concrete, there could be 30% strength reduction. So let's say for the structure application, if you want to use M40 grade concrete, and if you are using recycled aggregate, it could reduce the strength by around 30%, right? So it's a significant one, and you don't want to take the risk. That's why the code allows you, do not, no need to replace the aggregates fully, but you can go for a proportion of, let's say, 25% or 20%, and it could save a lot of amount of the natural aggregates. But yeah, why it is happening? Because of the added mortar. That means it is a time to improve the properties of the recycled concrete aggregate, right? If you are able to improve the physical properties of the recycled concrete aggregate, definitely we can increase the proportion of the aggregates for the structural applications. So there are various means on how to do it. So Rohit will be taking part how to address this added mortar. But what I suggest that at this source only, we can able to reduce the added mortar content. So normally in India, what is happening? The C&D waste will be going to the plant where they'll be resizing it. Resizing means they'll be using some crusher to crush the aggregate into different sizes: coarse aggregate 60 mm, coarse aggregate 40 mm, sand particles. Some plants they are using dry mixing. Some plants they are the dry crushing. Some plants they are using wet crushing in order to reduce the powder content, because some powder will be emitting during the crushing operation. So they are going for the wet crushing. So normally only one crusher is being used at the site, that is the jaw crusher. And we have seen that some crusher they are using the cone crusher. right, as a primary crusher. Only one crusher they'll be using. But what we suggest that why don't we use the different crushers? Okay, maybe we can use jaw crusher as the primary crusher. We can use the cone crusher as the secondary crusher. I have talked to many, crusher plant. They are saying we are using two stages of recycling. In both the stages, we are using jaw crusher, right? But can we go for the tertiary crushing? Means three crusher, jaw crusher followed by the cone crusher, followed by the impact crusher. Because our our studies on the natural aggregates, it shows that if you are going for two-stage crushing or three-stage crushing, the properties of the aggregate, the physical properties aggregate will be better. It will be having higher cubical, shape. It could have better interlocking capacity. That means it is the time we should come forward and then, should be able to optimize this crushing cycle. So if any one of you want to do your research work, obviously you can do it. The other reason is that if you see the recycle aggregate, if you are making one concrete, so this is the recycle aggregate and this is the concrete. So what happened normally, the crack, okay, if you're loading it, the crack might go from the new mortar, it can go from interfacial transition zone of the new mortar and the old mortar, it can go through the old mortar, and there could be many other failure mechanisms, but mostly failure mode 3 and 4, that is whatever you do, you increase the cement content, but the crack will always be going from the old mortar only, right? So it is not in our hands, right? That to improve the properties. So this is the main reason why the strength improvement techniques are not able to work in case of the recycled concrete aggregate. This shows that we need to shift the crack propagation. What we want, either the crack should go from the aggregate because the aggregate strength is around 100 MPa, or the crack should go through the new mortar, because new mortar as engineer we can optimize it, right? We can make it 50 MPa, we can make it 60 MPa. So what we want, either failure mode 5 or failure mode 1. So there could be many methods, right, which are available in the literature, and we are also following many methods. But mostly what we have found that if we are able to remove this mortar, then definitely we can improve, we can get the natural aggregates out of the C&D waste. So Rohit will be, throwing the light on the various mechanics on through which the aggregates can be extracted from the C&D waste. And last but not the least, nowadays what we are seeing that the fine aggregates, okay, how to use it, because the water absorption capacity of the fine aggregates will be significantly higher. So how to address it? And also along with the fine aggregates, we are getting the powder from the construction plants. And what we did some chemical analysis. What we found that this fine aggregates can be used again either for the cement regeneration as a filler material, or maybe it can be used to fill the gaps of the fine aggregates, right? So there are very few studies available on how to explore the potential of this recycled concrete fines, or we can call as powders, for the concrete applications, right? So I think I'm already about time. So yeah, so I'll be skipping few slides. But this was the C&D waste, right? What else? Right? C&D waste is around 500 million tons per annum. So can we explore the other alternative for the aggregates for concrete production? Definitely, we have the reclaimed asphalt pavement. That waste that we will be getting from the demolition of the flexible pavement or the bituminous pavement. Okay. And then can we use the industrial aggregates such as iron slag? Yeah, definitely we can use it. In fact, IS 383 is allowing to use the industrial waste like copper slag or the steel slag. And nowadays fly ash aggregates as lightweight aggregates are also being used. Now the research is going whether we can use the plastic aggregates or the rubberized aggregate in order to enhance the toughness properties of the concrete. So yeah, there could be different alternatives, but as an engineer, we should know the chemistry, the physics behind these aggregates. We know the chemistry behind the concrete aggregates and the wrap aggregates, but yeah, before making any decisions, we should explore the potential of different aggregates. So I'll be skipping these slides. Okay. So recently what happened, we came with a center of excellence. It is the first ever center of excellence dedicated for recycling. So IIT Madras, as the ministry has sponsored IIT Madras to start this center. Actually, we are calling it a prospective center of excellence. So what we'll be doing here, whatever the waste, whether it's the concrete waste, recycle aggregate, wrap waste, or the industrial waste, we'll be studying them and we'll be providing the solution. So the solution will not be based upon the material level, but we will be also, doing the research on how to reduce the generation of the waste during the construction and how to manage all these activities. If you want to get more knowledge on the first ever Center of Excellence, definitely you can visit the site. You can see so 11 different faculties who are working with the waste and how to manage the waste. They have clubbed together and started this Center of Excellence. So thank you. And now I invite Ram Viji to start his presentation, and then you can type your questions in the chat box, or you can wait until the Q&A session where you can unmute yourself and you can ask any question. So I'll unshare, and I request Ram to share his presentation.
Thank you, Surender, for sharing the scenario of R&D waste in India and abroad and processing of R&D aggregate. Next section will be by Mr. Ram. A small introduction about him. He is a joint MS PhD scholar at the Department of Civil Engineering, IIT Madras. He has a bachelor's in civil engineering from Madras University, Guindy. After his bachelor's degree, he has worked in R&D department, Lafarge Group for 2 years before joining the joint MS program in IIT Madras. His doctoral research focused on pathways of change in the institutionalization of construction, demolition, waste recycling projects, and is guided by Professor K. Satyanarayana and Professor Ashwin Mahalingam. He has 4 international journal papers, 4 international conference papers, and several other national publications. His research interests include waste management, sustainable construction, and organization change. Now it is over to you, Mr. Ram.
Thank you, sir. Thanks for the opportunity to talk to this seminar. A very good morning to everybody. The title of my talk is on strategies and policies to streamline demolition waste handling practices. Let's change now. So the outline of my talk is my broad motivation behind this topic, and a glimpse on the demolition waste handling practices in Chennai city, which we have taken as a case study as part of my research, and what is actually problematic with respect to Indian scenario as compared to what is actually working in countries with high recycling rate, especially European countries. And I'll discuss how to actually boost the recycling ecosystem with 10 effective strategic interventions or policies. And then I'll come to the topic. So about motivation, as you all might know, the United Nations have actually come up with 17 Sustainable Development Goals. And this talk will actually address 3 of those 17 SDGs, which is SDG 9, building resilient infrastructure and fostering innovation. SDG 11, which is building sustainable cities and communities. And SDG 12, which is responsible consumption and production patterns. So coming on to Chennai case study. So what is happening with the demolition waste in Chennai? So if you understand that, then we'll know what is the need for actually talking about various strategies and policies. So I'm categorizing the waste handling practices in 3 different phases: pre-demolition, demolition, and post-demolition phase. So in the pre-demolition phase, what happens if you are a owner of the building and you want to demolish, you go to the corporation or the local body and apply for a permit with all the required supporting documents. And to authenticate those documents and the information, the local body sends an AE to inspect the site, and once the information is validated, your permit is sanctioned, and then you can go ahead and demolish your building. However, while it is a good practice to actually have this system which is extensively actually validating all the information, what we're missing here is we are not focusing on the kind of waste that will be generated or how the waste will be managed in the process. Only thing is all the information, whether they are given they are the owner, real owner or not, that's a preliminary details that has been very validated, and no focus on waste management. In the demolition phase, what happens, as you can see in the slide, all the wirings and doors, windows, every other material that has economical value has been salvaged, and only your structure remains the same. Every other building, almost 90 to 92% of demolition happens in this way. So what happens to salvage materials? They are being carefully chipped and salvaged and stored, and they re-enter our supply chain uh, as they have a very strong informal network. And we should take care, if at all we are designing any strategies and policies, we should not disturb this informal and a very strong network. Then we actually use hydraulic breakers or pneumatic hammers to actually take down the building, and even the reinforcement steel that are embedded in the concrete chunks are actually salvaged using gas cutters, and they are sold. So this might be interesting to know that a major chunk of all the steel that we actually use are predominantly recycled steel, which is all the salvage steel goes to the yard and then way melted and then comes back in some chain. So in the post-demolition phase, only a debris remains, which is a mixture of concrete, brick masonry, and tiles and other ceramic products. What happens? They are usually shipped off in the night from the site and then being disposed in all places, bakes, road bakes, sidewalks, and every other place where you can see. And of course, the land mafia also has a control on it. And as you can see in the slides, they are being thrown away on all places. You can see, and it's not a very new phenomenon. It has been happening for so long time, and you would have even noticed on every road and sidewalks as well. Why? So actually, as Dr.Surender has mentioned, our recycling capacity is very low. So for example, the total installed recycling capacity itself in India is only about 2.5% of the total waste generation. And over on top of that, we don't even know how much quantity of waste we are actually generating because of the huge variation in and underestimation in single generation. So that is a kind of, to understand the magnitude of deficit, a country called Netherlands, with a population of 1.7 crores, has actually 120 recycling plants. India, with over a billion population, has only about 10 to 20 recycling plants. And that's the magnitude of deficit we're talking about. So what is problematic? So we have unreliable estimates as compared to extensive amount of surveillance that's happening in other countries. We do not focus on waste. However, they have mandatory preparation of waste management plans, crucial infrastructure, network of facilities in other countries. We are doing heavy demolition. On the other hand, many countries are actually doing self demolition where they do properly dismantle the structure. We have a mixed waste stream in terms of debris. On the other hand, in other people, the countries, they do on-site sorting. And of course, we have very inappropriate policies and structures here as compared to effective policies and adequate enforcement in various other countries. Right. So to counter this, in order to nurture a recycling ecosystem, what we need is effective policies. So based on content analyzing over 300 journals and secondary reports and stuff, we have actually decoded the strategies and put them or classified them in 10 different policy buckets. So those 10 different buckets are taxes, incentives, voluntary agreements, disposal regulations, research and development, mono landfill, demonstration projects, training schemes, waste exchange platforms, and waste management plans. So we shall actually look at each one of them in a bit more detail. Disposal regulations, of course, as the name indicates, is disposal restrictions. These are actually very common. And for example, in Netherlands, there is a complete ban on disposing your debris. That is the one which can be actually reused or recycled. In Hong Kong, there is actually a permission based on sorted nature. For example, if you have a mixed waste stream that has more than 50% of inert waste stream, that is concrete, debris, and bricks, you are not allowed to enter the landfill. That is, you cannot dispose them in the landfill. In another model called Alcuri's model, which is in this place, it is actually a deposit refund framework where you initially put a deposit during your permit application. And once you actually comply with all the waste management guidelines and do as per the proper disposal activities, then for furnishing a certificate back to the corporation or local body, you will be given the refund from the deposit that you have given. So these are predominantly ways in which you can actually regulate the waste movements in and around the city so that your waste is managed properly. The second policy is on taxes. Of course, it's very common and a stick mechanism to actually discourage unfavorable practices. The various taxes can be actually used in this waste management system. For example, there can be high disposal charges. There can be penalties for illegal dumping and unauthorized disposal. On top of that, there can also be vehicle impoundment that is actually practiced in Israel, for example, by the Green Police. So this actually is very needed because, for example, even today, as we speak, the fine that we actually truck owner pays if they are engaged in illegal dumping is just 2,000 rupees. So it is actually, it's very lucrative actually to do illegal disposal and get caught and pay the fine rather than take the material and do a proper waste management disposal. That's the kind of inappropriate systems that we are actually having in place. Hong Kong model is very effective. For example, as you see in the slide, from the construction side, if you take the material to a landfill site, you are actually charged 123 Hong Kong dollars for every ton. And there is also a restriction that you cannot bring in inert construction waste there. So what will happen? You will have to actually do on-site sorting, and then once you do on-site sorting, the inert waste are accepted in a separate waste management facility where you are only charged $27. And if you cannot do on-site sorting, you can actually take it off-site sorting and pay $100 and get it sorted, and then take it the non-inert fraction to landfills and inert fractions to waste management facilities. So these need to be put in place to actually facilitate recycling. The third and
Ram, sorry
important
to
thing is
disturb. Your voice is not enough. I think I have some comments. Just saying
yeah,
they can't hear you
yeah,
properly.
I'll probably raise my voice. So the third important structure is incentives. Of course, it's a carrot mechanism to provide benefits for environmental friendly practices. For example, in Hong Kong, adoption of recycled materials actually leads to exemptions in FSI calculations. So you actually get incentive to actually use recycled products. In the USA, there's actually a recycling grant that actually helps you set up recycling facilities. And in the King's County, it's not just money, but there's also something called recognition program where they give construction workers an award for each site that actually does waste management properly. So there are various kinds of incentives that you can plan. And one of the other things that we have actually noticed is this is not just on the regional level, but on a site level as well. The incentives actually have to be put in place. For example, there is a study that says incentives must be shared with all stakeholders at all levels. The labor who is actually doing on-site sorting at the lowest level should also gain some amount of benefits from the waste management activity, and therefore there must be incentive sharing across the levels in the waste management system. And people who are actually in charge of developing such systems should actually think about incentive sharing as one of the key measures that has to be put in place for better recycling or waste management activities. The fourth is, of course, on a regional level, it's mono landfill. For example, there are places where we do not generate enough amount of waste, and these facilities predominantly run on economies of scale. Therefore, this is actually a kind of strategy where you only landfill a specific type of material, let's say brick, only brick in this place, and therefore that prevents contamination with other materials, and therefore facilitates future recovery and higher quality of recycled products in future. So this actually observed in Austria, Sweden, Germany, and certain states of USA. And of course, this helps in very places where there is a lower level of generation. Then next one is demonstration projects. Of course, it's very common and it serves to actually familiarize the concept and boost confidence. It's, for example, even the India's first recycling facility in Burari, which is actually set up as a pilot plant in 2009, and it has been now upgraded in terms of capacity and has been running very well. So even the Central Road Research Institute has actually paved a 10-kilometer national highway using recycled aggregates to actually inculcate confidence among the stakeholders in using recycled aggregates safely. So such demonstration projects are actually needed in India as well, and more number of projects should be done. Of course, the next one is training schemes. Of course, the training imparts necessary skill and knowledge to perform senior waste management. It's been noted that almost 33% of on-site waste actually could be avoided through careful design decisions. However, lack of awareness actually plays a also. For example, in TIFAC survey, they have noticed that almost 30% are actually unaware of recycling possibilities of senior waste stream, and almost 70% of them are actually unaware of recycling techniques at all. So that's a kind of inadequate knowledge that we have about waste management and sorting and various other activities. So training schemes actually need to be put in place. Then, of course, research and development is a no-brainer to actually push the boundaries of a system. Only R&D enables development of recycling technologies, identification of waste, performance evaluation. Of course, the previous speaker has also talked about development of standards, regulation, and so for R&D, I need not mention much. That's actually one of the major indicators of to nurture the system. Voluntary agreements, it's pretty new. Voluntary agreements actually can drive responsible behaviors by bringing various stakeholders together. So this is actually effective in situations where it's very complex management issues might pop up. for example, in selective demolition, on-site sorting, utilizing recycled products, handling packaging waste. For example, let's say if somebody actually puts up a recycling plant, he'll not know how much demand or how many people will actually buy recycling products, right? So once enough people come together and sign an agreement or pact with them saying, I will procure this much amount of quantity from this much and this specific period of time, then obviously the recycler will actually have good confidence in terms of visibility in demand, and thereby better planning can be done. Of course, even the packaging waste, the one who is supplier can actually take back the packaging waste will be very, very helpful because he gets his raw material for his packaging products in an uncontaminated way, and therefore better recycling and better quality in terms of recycling products. So voluntary agreement is extensively used in European countries and various other environmental management systems, and is one of the effective ways to boost recycling. And the next is waste exchange platforms. Of course, it's born out of the internet. It actually helps solve the information mismanagement problem by matching supply and demand. As we all know, that land space is actually a scarce resource in construction projects. Therefore, construction personnel would actually get rid of waste as early as possible they are generated. And these platforms will actually give visibility and therefore enhances the chances of beneficial uses of such waste. The one which you're seeing on the slide is actually the statistics of the Madras Waste Exchange that has been launched to the Greater Chennai Corporation last year. And within 3 months, it is interesting to note that almost 1,000 buyers are actually registered as waste recycling product dealers, and almost 300 people have actually registered as sellers of recycling products. And 700 tons of material has been transacted in the 3 months. So this is the kind of potential that we're talking about in such lucrative business ventures. Of course, the CA also has a waste exchange portal that actually deals with hazardous and non-hazardous, and various other waste exchange portals are coming up, and it's been recently new. However, it's very old in various other countries. In the last, we're talking about waste management plans. Of course, any activity has to be planned properly before we start it. So therefore, we need to have a proper target. We need to put appropriate processes in place. And of course, it's a very must that responsibility must be clear-cut and mentioned clearly. And of course, there must be incentive sharing even in the waste management plan, and thus it can actually succeed. For example, in various Scandinavian countries such as Norway, there is actually mandatory preparation of waste management plans before commencing construction or demolition. And even in the waste management plans, you need to show that you are actually reusing or recycling 95% of the waste that you are going to generate in the activity. Then only you are actually granted the permit. So such kinds of structures are actually in need in our country. To conclude, these strategies and policies are absolutely essential to actually nurture the recycling ecosystem. This streamlining process is actually is needed for an efficient waste management system. And of course, there is actually a research need to evaluate the effective combinations of the strategies and policies, because while we know that these are the strategies and policies that worked in various other countries based on literature review, we need to have hard data and corroboration that this actually works and what are the effectiveness of various combinations of these strategies. Of course, researchers in attending this talk can actually pursue this field. And what we need is actually a C&D mission to foster sustainable development. Thank you for your patiently listening. Thanks.
Thank you, Ram, for sharing information about process, policies, training schemes, research and developments in demolition waste handling practices. So next, we will have a session on beneficiation techniques to optimize the C&D waste utilization by Mr. Rohit Prajapati. So just a brief introduction about Rohit. He is currently pursuing a PhD degree at Building Technology and Construction Management Division at Madras. His PhD thesis on the topic, a methodology for recycling of demolition waste concrete, supervised by Professor Ravindra Getu and Dr.Surender Singh. He holds a BTech degree in civil engineering from Rajasthan Technical University. After his BTech degree, he worked in the construction industry on multi-story residential building projects. Later, he got an MTech degree in construction management from Bhagwant University, Ajmer, Rajasthan. He jointly with Ram VG was awarded the UK India Social Innovation Challenge 2018 for the project on recycling demolished concrete. His research interests are C&D waste recycling, recycle aggregate, sustainability, and durability of concrete. Now, over to Rohit for a presentation.
Yeah, thank you, sir, for the introduction. I hope I am audible and my presentation is visible in full screen mode.
Yes, Rohit, you can continue.
Yeah. Yeah, so today I'll be talking about the beneficiation techniques to optimize the CND waste utilization. I'll be basically talking about the laboratory studies. Uh, this is the outline. I'll be talking about the background, which you have already seen in Professor Surender's presentation, and then the different beneficiation techniques, and then there is a small case study we have done at EM. So this is the natural aggregate, and this is the recycle aggregate. So as Professor Surender already mentioned, this is the attached motor here, and it is responsible for the higher water absorption, which is the main problem, and the mechanical properties are lowered. And then if you fully replace, it can reduce the concrete strength up to 30%. And then you have already seen this. There are many standards, but 100% is allowed only for lean concrete, and 20 to 25% is allowed only in plain and reinforced concrete applications, which are limited to sub-base, paver blocks, or non-structural applications. And then you have seen this failure modes also. So out of these failure modes, there are two common failure modes, which are failure of this adhered mortar, and there could be the failure at the ITZ between the old adhered mortar and the original aggregate. So to overcome these two cases, there are beneficiation techniques, which are removal of attached mortar. So we try to remove the attached mortar from the surface of the aggregate, and there could be surface modification. So I'll be talking about these two beneficiation techniques, and also a comparison between these different techniques. So like I said, mainly you can divide these processing or treatment techniques in two parts, where first is the removal of attached mortar and another one is the surface modification. So removal of attached mortar could be done by mechanical scrubbing and acid soaking and combined action of thermal and mechanical action. And there is also microwave heating, and there are other methods like ultrasonic cleaning. And surface modification could be done by coating with pozzolanic materials and impregnation of nanosilica or nanolime. And there are other methods which are polymeric treatment. So you basically coat the aggregate surface with PVA and other chemicals to increase the bond or to reduce the water absorption. And there are biodeposition of calcium carbonate and curing or carbon conditioning. So before we go these processing or treatment techniques, let us go through the conventional crushing process. So like Professor Surender and Ram mentioned, there is a weighing, segregation, size reduction, and there are crusher used, maybe jaw crusher and impact crusher. And meanwhile, you separate the rebars. And then there are two methods which are currently practiced in India. One is the wet washing methods, where you remove the silt and fines, and there is one dry process. After this, there is size-based cleaning. So advanced treatment could be done after this process, or maybe can be done after the primary crushing also. So let us see what are the treatment techniques are available. So first is mechanical rubbing, where you can use a eccentric shaft rotor, and the RCS pass between this outer and inner cylinder, and it rotates and it removes the attached motor. Other one is simple, which is similar to ball milling, and in this the motor is removed by scrubbing against the iron balls, and there are separate parts of the drums. And at laboratory scale, people have been doing in the small milling machines or the abrasion machine as well. Next is acid soaking. In this, RCA is soaked in acid for 24 hours, and then water is added to remove the acidic solvent or the corroded part of the aggregate. So granite or the other aggregate are more stable, whereas the mortar is prone to the acid corrosion. So it is dissolved and it is removed, and then it is soaked in water, and then what you get is the benefited recycle aggregate. Common type of acids are used are HCl, H2SO4, phosphoric acid, and usually 0.1 molarity is used. Next is the microwave heating, where heating is provided through microwaves, and uh, this basically acts as the ITZs. So basically, you have a different dielectric constant of the motor and the aggregate. So differential thermal stresses are developed at the interface of motor and aggregates, and then it is delaminated, and you get clean aggregates. So there is a pilot scale plant in Singapore, where they have used 10 kilowatt for 1 minute, and then after the microwave treatment, they suddenly put the aggregates into the water for thermal shock, and then it is recycled. Other one is the combined action of thermal and mechanical process. So first the crushed aggregates are heated. The temperature could be from 300 to 500 degrees C, and then with the combined action of heating and mechanical process. So basically heat will dehydrate the cement products, and also additionally there is differential thermal expansion at the interface of aggregate and mortar. And further milling process is used to remove this the loose particles or the loose attached mortar. And there is a commercial portable plant in Japan where they've used 300 degrees C, and then two stage of milling processes, different for coarse and fines, and they could produce very high quality recycled aggregates. The capacity of this plant is 5 ton per hour. Coming on to the next type of treatment where the modification of surface is done. So it could be done using the pozzolanic materials. So you can use silica fume and fly ash or cement. So basically this is the process where first you try to coat the aggregate with the pozzolanic material, and then after several stages of mixing and adding the different constitute at different times, you get the concrete. So with this concrete, what happens is uh, the ITZs are densified. Also, this attached mortar, which is porous and there could be some cracks. So these are also filled with the pozzolanic materials. Next is the biodeposition of calcium carbonate. So using a bacteria, uh, the porosity or the pores are pores and cracks of the recycled aggregate is filled. So this bacteria attracts calcium ion and produces calcite or calcium carbonate, which also requires a culture medium, which is basically urea. So this process, the bacteria forms spherical depositions of calcium carbonates on the surface. So this will densify and improve the aggregate properties. Next, and a very hot topic these days is the CO2 curing or carbon conditioning or carbonation of the recycled aggregates. So basically there is a chamber, and so this will be there is a vacuum pump, and then the CO2 is CO2 is CO2 the CO2 tank. This temperature this chamber is pressurized with the CO2, and there will be carbonation of these recycled aggregate, which is a kind of a permanent sequestration of CO2. So this is one experimental setup, but now there are a lot of startups and companies are coming with different products such as concrete blocks made by CO2 curing, and there is now a cement also, carbon cured cement, in which the fresh cement, the CO2 is injected. So let me give you a comparison of the different processing methods based on what are the state of art available today. So there could be positive and negative remarks for each method. Like mechanical rubbing, we have high energy consumption, multiple stage process. Acid soaking has high water consumption and problem of handling, and there could be contamination of sulfate and chloride, which could be a durability problem. Microwave heating has this arching and fireball formation, and it involves specialized equipment, of course. And conventional heating and scrubbing, as we can see, it has mass scale production ability, and the improvement in water absorption is high. up to 80%, but there is a high energy consumption, but you get the high quality aggregates. So other slide is on, this slide is on the other type of beneficiation method. So where you are using polyzonic material and PVA and carbonation. So we can see there is an improvement. Some are suitable for mass scale production, some are not suitable. So like if you see the polymer impuration, the cost is very high, and this is a multiple stage process. Carbonation has a high quality aggregate. It improves the ITZs. And then you have the biodepletion, where you need humid environment, and the bacteria could be killed at high environments. So now coming up on the case study we have done at IITM. So this is based on the thermomechanical treatment. So I'll be discussing about the properties, the process, the properties of beneficiated aggregate, and the properties of the concrete, which was made using this beneficiated RCA. So in Chennai, there was this demolition site. So we got the waste from it, and already the rebars were removed. And then we did the size reduction. We optimized this process also. We used different size of concrete pieces, and then we used electric furnace to heat this. And various temperature was tried, starting from 350 degrees C to 500 degrees C. And then after the cooling and the mechanical milling, you got these three products: coarse aggregate, fine aggregate, and the concrete fines. So the coarse aggregates are size from 20 mm to 4.75, and your fine aggregate is 4.75 mm to 300 microns. And this is the concrete fines, or the powder, which is less than 300 microns. So you can see after the treatment, the aggregate looks like this. You can see that almost all the attached mortar is removed. So let me just show you the aggregate piece. Yeah, so the comparison of this beneficiated aggregate with granite aggregate, laboratory jaw crushed aggregate, or you can say untreated aggregates. And we also have got a sample from the industrially produced recycle aggregates from Bangalore. So you can see these are the three types of aggregates. So as far as the physical properties is concerned, and we all know that water absorption is a good indication when you try to compare the different kind of recycle aggregates. So you can see that we were able to bring the water absorption up to 1%, close to 1%. And usually it could be 6%, 5 to 6%. And the mechanical properties are also as good as the granite aggregates. The next slide, let me show you the fine aggregates. Yeah. So here we have tried to compare the beneficiated aggregate with crushed aggregate or untreated fine recycle aggregate and the river sand. So you can see that water is around 6%. It is not comparable with the river, but definitely better than the untreated recycle aggregates. We have also tried using this aggregate in the concrete. Let me just give you a glimpse. So we have replaced coarse recycle aggregate with the granite aggregate at 0%, 20, all the way up to 100%. So if you see that, so the bottom line is with the treatment process, you can actually optimize the use, and the use you can use up to 100% of the recycle aggregate after the treatment. So before ending the presentation, I would like to acknowledge the financial grant from UKRI DST project and the laboratory used in MPCM lab established by the FIST grant, and the UK India Social Enterprise Education Network for the financial help, and lastly the Ministry of Human Resource Development, Government of India. Thank you.
Thank you, Rohit, for the presentation on the various beneficiation techniques to optimize the C&D waste utilization. So now it is open for the question and answer session by Surender Singh. You and the team can take up the Q&A session. I think so. We are already having a healthy conversation in chat box.
Yes,
And
there are
participants,
many direct messages.
yes,
So,
yes. And then if participant interested, you can unmute yourself and then you can ask your questions. Thank you.
so there were more than 50 direct messages. Okay, I was answering them. So Rohit and Ram, if you're getting some direct messages, I request you to start replying to those queries. And if anyone has some questions, yeah, Nokia 6.1. Uh, sorry, that was a name that was visible. So
Sir,
yeah, you
I'm
can unmute it.
Priyanka. Yeah,
Hi,
yes, sir.
Priyanka.
Yes, sir. Hello, sir. Sir, actually, I found from literatures that there are that is the challenges being faced in the construction and demolition waste practices that being the unstable source of incoming C&D waste, right? They have given like manual sorting and other type of sortings are the only solutions for that unstable source. So how what we are following in India that for this challenge actually?
Okay. Yeah, thank you for rephrasing your question.
Yes, sir.
Actually, what happens abroad, they have started using AI technique, okay, artificial intelligence technique, in order to sort out some of the waste, different sources of the waste, different contaminants. For example, uh, based upon the color, they are able to remove the plastic waste. Based upon the specific gravity, they are able to remove the waste material, the waste paper waste. So those are the some of the techniques that are usually followed abroad. Maybe you can call them as laser technology, some other techniques. But in India, still we are doing the manual technique. Okay, manually we are removing all the other contaminants at source. So we highly suggest, what if you want to do the segregation, do it at the source. So the burden on the the crusher plant will be reduced. So normally, if we follow the Delhi model, where what we have seen that they had different sites. So at source they'll be removing the contaminants, and then they'll be shifting it to some other point. At that point also there will be few manual techniques, and then they'll be after that they'll be again sending it to one more source, and then they were sending it to the Burari plant where the crushing usually takes place. So maybe that could be the only solution at this moment. But yeah, in the future we'll be having some other optimized techniques, so automatic technique in order to remove the contaminant. So like for the steel, so I remember in the Bangalore crushing plant, they were using the magnetic magnetic belts. So whatever the steel that is coming, it will be attracting it. But for the other waste, right now it's the manual segregation is only the alternative.
Yes, sir. Thank you. If you don't mind, shall I ask you another question?
Yeah, sure.
Sir, I came to know that the type of processing that we are following for C&D waste has also an impact on our environment. Like the type of machinery that we are using, maybe the crushers. Is it so? Is it have that much significance on the environmental impacts?
Yeah, actually, environmental impact. So we generally quantify it in terms of different parameters, like how much CO2 emission is there, how much mainly environmental is the CO2 emission. We could have other parameter also. So for that we have to do the life cycle assessment. Okay, so we can only comment on this after doing the life cycle assessment. But the main issue is that we are not able to. So if you compare it with the when you are milling the natural aggregates. Okay, so milling the natural aggregates, you are demolishing it, you are breaking the mountains. So lot of amount of the CO2 is being generated there. So in this scenario, we have to compare, having one more condition, that in one case you are using two crushers, and then you have to compare with the natural milling of the materials. In that case, I think the we can get a clear picture. But yeah, what we have seen, the transportation cost related to the procurement of the C&D waste adds a lot to the CO2 emission, because for the transportation we'll be needing the petrol and other fuels. So as far as the crushing is concerned, I don't think right now there is a study available. But yeah, Ram, if you want to comment on that, you can surely do. Okay, but yeah,
Yeah.
so we have to life cycle.
Yes, sir. So actually, nice question. But usually in life cycle assessment, what we do? We do actually comparative LCA. For example, we are right now doing natural quarrying, and for even quarrying processes, we do crushing and then resize the material, and we use natural aggregates. And in recycling process as well, we actually take the debris, crush it again, and sell the recycled aggregates. So in a comparative LCA, these two processes that are common in both processes will actually cancel out each other because it is predominantly a comparative LCA, and therefore your recycling will actually stand beneficial as compared to crushing, because the processes of crushing is common in both. So therefore, when you're talking about impacts, your impact specific to recycling processes will actually play a role here. For example, as Dr. Surender has pointed out, transporting the waste material from the sites to actually the recycling plants contributes one of the major chunk of impacts as compared to any other impact. Yeah, I think that's clear.
Yes, sir. Thank you, sir. Thank you.
There is one question in the chat box. James.
Chat box we can reply.
Okay.
There are some raised hands, so I think we should address them. Vadiraj
So
Rao.
much.
Yes, sir. Good morning.
Good morning.
Thank you for the presentation. I have a question. Can you really relate the amount of the matter, the water content on the aggregates to the compressive strength of the
Okay. Yeah, I read that question in the chat box also.
Yeah, same thing. Yeah.
See, I don't remember any study available relating the mortar content with the compressive strength, because if you see the fundamentals, it is not really the mortar content. It is the mortar content sticking around the periphery. Okay,
Yes.
let's say if this is a recycle aggregate and the mortar is here only, so it's hard to relate it with the strength, right? So maybe the how much surface, maybe the surface of the mortar in binding with the aggregate could be related with the strength. Okay, but yeah, surely we have to study this parameter, how the mortar content can be related.
What I mean is the recycled aggregate mortar content.
Yeah, that's what.
Yeah.
So this is the aggregate. If it is surrounded from the four sides with the mortar, so the interfacial, like as highlighted by Rohit, the interfacial transition zone will be there, will be poor. Okay, from all the directions, and then it will be easy for the crack to propagate from it. But on the other hand, if you are having a mortar content sticking here only, let's say 60% mortar content is sticking here. Okay, and if we are loading it here, the crack is coming from here, so it will take some time to cracks to propagate from this ITZ. So in that case your strength will be higher, so it's really difficult to relate with it. Okay.
Yeah, I have one more question. Can you really relate the strength of the old concrete to the recycled aggregate and then to the new concrete?
See, strength of the RCA. Okay, normally what happens, hydration is a never ending mechanism. Okay, if you get the water, hydrated compounds will be, coming and coming. So if you see the 28-day strength, 28-day strength around, we are able to achieve 98% hydration in 28 days. 90 days, you can say 99% of the strength is achieved. After that, if you are keep on, submerging in the water, so the hydrated compounds will be normal. Okay, will be similar. So I don't think when the concrete has been fully hydrated, okay, it will be having some varying effect on the performance of the recycle aggregate concrete.
Just
Thank
to
you, sir.
add,
Thank you.
just to add, so when you have a normal concrete and when you have high strength concrete, so when you crush it, of course, the bonding between the overlaid mortar and the original aggregate will be better. So this way, that failure mode will not pass through the overlaid mortar. So you could expect a little bit more strength from that.
Thank you, sir. Thank you.
Hello.
Yeah, hi.
Yes, sir. Good morning, sir. Nice presentation, sir. I am Dr. Kumar. I have one small doubt in the application of recycled materials, particularly the recycled coarse aggregates. So as per RILAM recommendation, the only maximum of 20% is permitted for structural concrete. Even after treatment, we are struggling to remove the attached mortars also, adhered mortars in the recycled aggregate. So is there any efficient technique is there to increase the core strength of the aggregates, sir? Because whatever we are giving, even we treated only treats the surface of the recycled aggregates. So it won't give much strength to the core strength of the aggregate.
Yeah, right.
So
So generally what happens, Yeah, see, one thing is that, as far the application is concerned, we are still having one more presentation. Okay. So I think, we are already delayed. So maybe we can have that presentation first, and then afterwards we can discuss all these parameters. But yeah, I'll be addressing your question. See, generally what happens, we did, see, like Rohit has highlighted the various beneficiation techniques. Okay. So in most of the cases, if you try to address the mortar, okay, reduce the porosity of the mortar, to some extent, it could increase the strength. But, removal of the mortar is the ultimate mean in order to enhance the performance. But if you want to improve the properties of the parent aggregate, so maybe what we have seen during our study is that while you are heating it, and after that, if you are beneficiating it, because of the dual effect of heating as well as the abrasion within the milling equipment. So what we have seen, the physical properties of the aggregate is also become, higher, maybe because of the combined effect of the alternate heating and the scrubbing action. So we have seen it. Okay, but yeah, apart from this thing, I don't think using any acids or something will enhance the properties of the aggregate itself. Maybe it can reduce it. Okay, so yeah, so we have to look for a proper technique. So one of the technique is thermal mechanical beneficiation, which can surely will be, improving the properties of the concrete. Okay, so yeah, and maybe right now there are many other questions. So I request all the participants to write down your questions here in the chat box, because we are delayed by some time. So over to you, Kanan sir, and then I'll be
Okay, sir.
addressing all the questions in the chat box.
Okay, sir.
Thank you.
Okay. Thank you, Surender. I think so. More questions can be posted in the chat box, and Surender and his team will be addressing the question chat box. Apart from that, Surender will be sharing his email, and participants can also get address from him later on. So before going for Dr. Kalgal presentation, we'll be have a short promotional video of UltraTech Cement Ltd, without whose presence this meeting would have not been possible. I request Jagan to play the video.
The year was 1983. India had made history. It was the time when we as a nation started believing that anything is possible. Around the same time, we took our first step in the transformational journey of India. We laid down the foundation of Rajashri and Vikram Cement Works to help every Indian realize his dream of owning a home. It was with this purpose that we started our journey. In 1988, the Birla White Cement plant was commissioned. In 1998, we built India's first RMC plant to transform the country's landscape at speed. Our common mission brought our cement businesses together in 1998. With the acquisition of L&T Cement, we created our new identity in 2004. In 2010, we acquired Star Cement. To keep pace with the demands of a rapidly growing nation, we expanded our capacity organically and inorganically. Along this journey, we laid down the tracks of progress and built the gateways to a new India. We connected villages to cities and made urban commute faster and safer. From naval bases to world-class ports, and from water reservoirs to stadiums, together we've made it all happen. We've built one of the largest logistics networks in the country and have invested in skill development of masons across India, including women masons. UltraTech's initiative, India Next, was launched 4 years ago to engage with the brightest minds in engineering and architecture community to build a more meaningful future for India. The acquisition of JP Cement units established our presence in Himachal Pradesh, Central India and Coastal Andhra Pradesh. An India cement player and a leader in all zones. We continued our successful organic and inorganic growth with the commissioning of Dhar Cement Works, the acquisition of Benani Cement, and the merger of Century Cement. With this, we crossed an important milestone, adding an unprecedented 47 million tons in just 3 years. This addition is more than the capacity of the next largest player in India. Today, we are at the threshold of yet another exciting chapter of our and the nation's growth. Our vision of being the leader in building solutions has driven us to build the India of tomorrow. What started as a single plant 36 years ago has grown into 52 cement plants and 100 plus RMC plants. Today, we've become one of India's most valuable brands, with a portfolio of 56 product offerings, catering to 90,000 plus channel partners across the country. The trust that you have reposed in us has helped us reach the spectacular milestone of 100 million tons plus capacity in 2019. We continue to anticipate our customers' changing needs and provide innovative products and solutions, because we believe that whether you are building your home or an iconic infrastructure, it is not just a structure, but your badge of reputation, and hence you would want only the best. India's #1 cement, UltraTech, is always with you on the path of progress.
Thank you, Jagan. So now we go for the last session of our program. The presentation is by Dr. Manamohan Kalgal, Technical Advisor to UltraTech Cement Private Limited. So you'll be presenting on the topic use of aggregates in concrete, need for sustainable approach. So Dr. Manamohan Kalgal is a stalwart in concrete technology, and he's a person who doesn't need any introduction. So formally, I'll just introduce him to the participants. He has received his PhD in concrete structures from Indian Institute of Science. He spent more than 20 years in teaching, research and consultancy. He was a professor of civil engineering at Mr.Ram Institute of Technology, Bangalore. Moved from academics to industry in 2003. He was heading the technical division of a precessing company, BBR, till 2007. Later on, he joined UltraTech Cement Ltd as head building products division, and later took over as joint president and head technical services. He is presently technical advisor to UltraTech. He is actively involved in several professional bodies. He is a fellow of Indian Institute Association of Structural Engineers and ex-VP South of the same association. Fellow of Association of Consultant Civil Engineers, ACC, and ex-Secretary General. Member of Indian Concrete Institute and was president of ICI from 2015 to 17. He was the vice president of Asian Concrete Federation for the years 2017 and 18. Actively involved in organizing several national and international conferences. He was a AICTE INAE Distinguished Visiting Professor to BMSc from 2012 till 2017. He has been honored with the Eminent Engineer Award by Institution of Engineers India at their annual convention in 2018. Equerry UK IERA Equerry Congress Committee honored him in March 2017 by dedicating one conference in his name. With a short introduction, I request Kalgal sir to take over session. Thank you, sir.
Thank you, Professor Kannan, for a long introduction. And good morning, all concrete friends. This particular talk, which I am planning to give, is basically to do with the overall view of the scenario of concrete and the need for sustainable approach from the point of view of the use of aggregates. I hope I am audible and my screen is visible. With that, I will continue now.
Yes, sir.
Yeah. we've been talking of sustainability, and everybody is talking of sustainability as of now in several fields. And also construction is one major field in which sustainable development is being talked about. So in sustainable development, basically we define this development as the one which recognizes the need of everyone, because development cannot stop. Development will happen, but it should recognize the needs of everyone. It should maintain stable levels of economic growth and employment. It should also use the natural resources prudently, and while protecting, if possible, enhancing the environment. So we look at what are known as, the three pillars of sustainability: the social, the economic, and the environmental impacts of any developmental work that we take up. So a development which takes care of, or which considers social and economic issues, is said to be an equitable development. A development which takes into consideration environmental and economic issues is said to be a viable development. The one which takes care of social issues and environmental issues is said to be a bearable development. So the one which takes care of all the three aspects, or the three pillars of sustainability, is said to be a sustainable development. This is one way of looking at what is sustainability and what is sustainable development from the point of view of sustainability. Now coming straight to concrete, because there is hardly any time left, half an hour is what is given to me. And concrete, it has many green benefits, not the color of green that is shown here. Concrete per se has a lot of green benefits, and it makes it a sustainable choice. Let's see how. I mean, we have to consider, as was mentioned earlier, speakers were talking about the entire life cycle. That is, from the time extraction takes place, processing of the extracted material happens, construction process, the operation that are involved in construction. Later, when the life is over, the demolition of these constructed facilities and possible recycling of the material. If you consider all of that, which is basically the life cycle process, concrete makes a significant contribution to the triple bottom line of environmental, social, and economic development, which means it is a sustainable development. No other material can give you this kind of benefit very holistically. For example, if you take the production of concrete, which consists of about 15% of cement, or 10 to 15% of cement, it results in the emission of about 0.13 ton of carbon dioxide per ton of concrete. Because cement, if you look at 1 ton of cement, right now they say if it is OPC, it is about 763 kgs of equivalent carbon dioxide. So in concrete, we are using only 10 to 15%. So per ton of concrete, we have, around 76 kgs or 114 kgs of carbon dioxide emission. Now, if you look at all other construction materials, for example, from aluminum to, stainless steel, or reinforced steel, and so on and so forth, we see that concrete is only 1.4, gigajoules per ton. That is the production energy for concrete, compared to 270 gigajoules per ton of aluminum. Of course, we don't use as many tons of aluminum as we use for concrete. However, I'm just trying to give you a feeling that concrete is not a very harmful material as it is made out to be. You have no other material which is much better than this. Aggregates, of course, is 0.25. I have brought in because we're going to talk about aggregates. So concrete manufacturing results in less carbon dioxide per unit than almost all other construction materials. So it is a construction material of choice at this point of time. Now, though we know that concrete is sustainable, we want to make it as sustainable as possible, or more sustainable. So there are several ways of doing it. One is, of course, making the cement itself more sustainable. How do we do that? We use less energy intensive kilns. We use supplementary cementitious materials so that the OPC component is reduced, or we use new types of clinker which emit lesser carbon dioxide, use alternative fuels and renewable energy during production process, and if possible, produce a clinker-free cement itself. So these are the initiatives that people are thinking about for making concrete sustainable through the cement route. Now, if you look at alternative materials in concrete, we generally talk of alternative cementitious material, and we also talk of, alternative aggregates than what we are right now accustomed to using. People are also talking of sequestering carbon dioxide in concrete, which was mentioned by the previous speakers. We are planning to produce clinker-free concrete. That means without any cement in it. For example, geopolymer concrete. So efforts are on to make sure that we reduce the impact of construction activities on the sustainability, right? So we are talking of what are known as wastes in concrete being converted to assets. That is, converting liabilities into assets is what people are now talking about. Now, with a whole gamut of things here, which is not possible to be covered right now, we are going to talk of only use of alternative aggregates, because that is the topic that has been chosen for this presentation. Now, when we look at aggregate in concrete and mortar, quickly we can see that in mineral terms, aggregates are the pieces of crushed stone and gravel used in making concrete, or it is also used as a bulk fill material in the construction industry. Aggregates are very important because nearly 75% of volume of concrete is made by aggregates, and they are arbitrarily classified as fine and coarse on the basis of size. Say anything which is less than 4.75 mm and below is sand, and above that is considered as coarse aggregate. So the aggregates influence the properties of concrete and mortar through the rock type, size, shape, texture, chemical and microstructural characteristics. Although it is supposed to be an inert material, there could be some impacts when we start thinking of alternative aggregates, as was again mentioned in the previous speaker's talk. So in the construction, now what is the impact of this aggregate itself? If you look at it from the triple bottom line of sustainability, the extraction of aggregates and processing of aggregates and bringing it to the construction site and using it, they have several impacts on the three bottom line. Environmental impacts could be like release of emissions and generation of wastes at various stages. Social impacts could be truck traffic, transportation, potential nuisance to neighbors, dust emission, and so on. Environmental impact could be, consumption of water and energy for the, extraction and processing of the aggregates, and also transportation. So in sustainable construction, it is required to explore on a project by project basis. The assessment should be done of the potential environmental, social, and financial impacts arising from the use of aggregates. We don't seem to be doing it right now. We only talk of cost, we only talk of strength. We never talk of the potential impact of whatever we are doing. Now, the seeking of triple optimal, triple bottom line solution from sourcing to application is what we are going to talk about or keep in mind while discussing the future things. So traditionally, most aggregates, materials have been obtained directly from the stone quarries and from the riverbeds. The sand is from the riverbeds, and the resource of materials appears to be very, very abundant, as was shown in the earlier slides also. Now, we must realize that they are a finite resource. It's not infinitely available. Also, as was very rightly brought out by Professor Surendra, most of these aggregates are right now in inaccessible or unquarryable areas like forests and so on. Similarly, river sand, we are not able to exploit because the damage that is getting created in the riverbeds. So our continued use will obviously lead to their depletion. If not in 40 years, it may be in 80 years or in 100 years, but human generation wants to live for much more. So we have to think of seeing how we can limit the utilization of virgin materials. The global consumption of construction aggregates right now is expected to reach around 63 billion metric tons by the end of 2024, whereas it was 43 billion tons, in 2016. So already 1.5 times it's likely to go up. So we will talk right now not of primary aggregates, but we talk of secondary and recycled aggregates. The recycled aggregate component has been excellently presented by the team from IIT Madras. So these are the alternative forms of aggregate that we want to use, which are other than the direct excavation and primary mineral sources. The terms secondary and recycled aggregates are often regarded as interchangeable words, but actually there is a distinct difference between the two. Now, the recycled aggregates are produced from materials sourced from the recycling of construction and demolition waste, which has been dealt with. So I will not talk about this. We talk of secondary aggregates, which are usually byproducts of other industrial processes, which have not been previously used in construction. Those are secondary aggregates. It could be from natural sources like slate aggregate, China clay stent, etc., or it could be from the manufacturing of various other processes like slag, coal bottom ash, and so on and so forth. So while looking at making the concrete more sustainable from the point of view of sustainable aggregates, as was mentioned, we have two alternatives. One is the recycled aggregates. The second one is the secondary aggregates. Also for sand, the river sand, the alternatives that people are looking at are crushed stone aggregates, manufactured sand, C&D, waste sand, marine sand, industrial waste like pond ash, and so on and so forth. So the primary source or the guideline for us as far as the coarse and fine aggregates for concrete is our IS 38322016, based on which we will have to utilize judiciously all the alternatives that we are thinking of. So the code, the 383, makes distinction between the aggregates in the form of natural sand, that is the fine aggregate resulting from natural disintegration of rock over millions of years, which has been deposited by streams or glacial agencies. And the crushed stone sand is the fine aggregate produced by crushing the hard stone. Of course, the word manufactured sand is very commonly used for crushed stone, but the code after 2016, we are not supposed to use manufactured sand for the stone aggregates or the crushed stone sand. So it's fine aggregate produced by crushing hard stone is called as crushed stone sand by the Indian Standard Code. Now, there is also what is called as crushed gravel sand. If you crush the natural gravel, then it is called as crushed gravel sand. You could mix both of them and it is called mixed sand. And there is what is known as manufactured fine aggregate as per 383, which is fine aggregate manufactured from other than natural sources, because the quarried material, the granite or basalt is natural material. Here, fine aggregate manufactured from other than natural resources by processing materials, by thermal or other processes like suppression, washing, crushing, scrubbing, etc. These are designated as manufactured fine aggregate or manufactured sand. So manufactured fine aggregate can be recycled concrete aggregate also. Now, if you look at the Indian scenario as far as sand is concerned, now the sourcing of sand in India is through river, which is riverbed or floodplain, lakes and reservoirs, agricultural fields, coastal marine sand, paleo channels, or manufactured sand, and CSS, that is crushed stone sand. So more than 90% in our country are extracted from riverbeds and banks, which we are accustomed to utilizing for quite some time now. And the Government of India, the Ministry of Environment, Forest and Climate Change, in 2020 January brought out enforcement and monitoring guidelines for sand mining. So that is where the control started being applied very rigidly. It was supplemented by another guideline called Sustainable Sand Mining Management Guideline 2016. That is the latest that the government has brought in, where there is an amendment, and hence I am mentioning of 2020 guidelines. The 20 guidelines for sand mining also stresses on protecting the rivers and habitat species, including turtles, and calls for sensitive areas to be declared as no mining zones. So it has also called for using latest technology for surveillance of illegal mining and estimating the reserves. A United Nations report also has said that led by China and India, world is mining sand at unsustainable levels. So we have to be very, very careful and responsible. Now, as all of you are aware, the deadly world of India's sand mining mafia is there all over the country. Now, you have seen so many, news items which will be flashing in various, newspapers saying how the mafia is trying to control the, illegal sand mining that is happening. And the reason is because there is a tremendous demand for sand. The only way to beat this mafia is to reduce the demand for natural sand, not just by enforcing the rules, but by making available alternative sand which is cheaper and better than the river sand. That's the only way to beat the mafia, according to my feeling. So these are the newspaper cuttings you can see from right from Tamil Nadu to Ganges area to Uttar Pradesh. Everywhere there has been sand mafia. Now, considering the problems related to natural sand, switch over to this crushed stone sand or M sand. Looks inevitable because the environmental regulation, non-availability of natural sand, and quality and consistency issues. Though people feel that river sand is very, very of good quality, people don't realize that there are a lot of profiteering people who are mixing a lot of materials into so-called river sand, and hence consistency is a big, victim there. That's what is happening there. And another reason why alternatives are not being thought of is because of the apprehensions related to this construction practices where alternative materials like crushed stone sand, M sand, or recycled concrete aggregate or recycled waste material is to be used. So what we have to create now, the opinion and the understanding among the people that CSS or M sand is different, but if it is engineered well, it can be better than river sand or the natural resources. So not just concrete manufacturing, but concrete handling practices also need to be improved to make better concrete structures using these crushed stone sand and M sand. So what are the factors that define sand quality? It's the gradation, it's the particle shape, it's the cleanliness, and the texture. So quickly, let us look at some of the alternatives. I'll deal with only one or two of them. The most popular or the most necessary and fairly abundantly available one now is the crushed stone sand, and more colloquially called as manufactured sand. So here and there, that word might creep in. So as was mentioned, this is a purpose-made fine aggregate produced from a suitable source material. The rock is crushed and sized in a quarry to make coarse aggregate, and this process generates fines also, which are finer than 5 mm, and they tend to call this as sand, but actually it is known as crusher dust. Now, what is a dust? That dust is actually a fine screening, and these are generally flaky materials, and they cannot be called as manufactured sand or crushed stone sand. Crushed sand is made in a very, very methodical manner using vibrating feeders, jaw crushers, cone crushers, vertical shaft impactors, vibrating screens, and so on and so forth, to make a sand which is as good as or better than the river sand that we are accustomed to using, and they are available as fine artificial sand or coarse artificial sand to you. So this involves crushing, screening, and washing, and separation into discrete fractions. So these are cone crushers and jaw crushers, which was shown by the previous speakers also. And this is the most important, the vertical shaft impact crusher, because this is the one which makes the sand the way it is to be made by how the sand got manufactured. The nature hit one rock against the other, so it is stone hitting against stone or stone rubbing against stone, which made the larger stone particles or gravel into sand. So this vertical shaft impact crusher tries to simulate that natural formation process, and hence you will have particles between cubical and the spherical shape, which are available for you to use as crushed stone sand. So the end product looks something like this, because again, it depends on the origin of the material. If you were to create it with basalt, it might look darker also. So there is a washing unit which is there in many of these plants. This is to avoid very fine particles, especially particles less than 75 micron. And also there may be facility for reblending. You know, if the gradation is not working out properly, there can be machines used for reblending. This is a typical sand manufacturing plant. These are photographs of sand manufacturing plants at various places. Quick comparison about the natural sand, the crushed stone sand and the quarry dust is that natural sand is a naturally occurring material. It is possibly carefully selected and sometimes processed, whereas crushed stone sand is a fine aggregate specifically designed and it is always processed properly. And quarry dust is unprocessed and you cannot be sure of what its quality is. Similarly, the natural sand is well shaped and graded most of the times. And in crushed stone sand, it is always well shaped and graded. And quarry dust can be very gritty and flaky. Now, you must be careful about some unscrupulous manufacturers who might be adding quarry dust to the crushed stone sand. Then there will be some issues. There could also be issues in quality, and there should also be issued, certain properties or control on properties might not be there if you are using river sand or quarry dust. But generally in crushed stone sand, of course, the manufacturer has to be evaluated to check what kind of facilities he has. So how to identify crushed stone sand? Basically, if you hold it in your hand and rubbing it with hand, you can find out whether there is quarry dust because it will stick to your hand and you can visually make out. Also, what is easily done or possible is most of you or all of you have mobile phones and smartphones. You just take a photograph of the sand that is supplied as crushed stone sand to you and zoom it. When you zoom it, you will see whether the sand particles are cubical or not. For your, for your information or for your benefit, the photograph is shown. On the right side is river sand, left side is good quality crushed stone sand. Both of them are of 2.36 millimeters. So they will appear identical. But if there is quarry dust mixed in it, very easily you can make out when you zoom the photograph taken from your smartphone. Very simple. So the poor quality crushed stone sand will have flaky particles is something that you must remember to identify or distinguish. So crushed stone sand, actually, strictly speaking, should have compliance to several standards, but you may not do it every day. But it is advisable by the code that you do all these tests. See, there are 11 tests that are, identified. This is required when you are, assessing the manufacturer and fixing up or finalizing the manufacturer before you order the crushed stone sand from the manufacturer. So these are the tests, but you can't do it on a daily basis, but you can do it once in 3 months or whenever you find that there is some change in the raw material. So the performance of crushed stone sand, you have to be very, very watchful about the grading, particle shape and surface texture. And the water demand is likely to be affected because crushed stone sand is actually a very bone dry material. River sand has certain amount of water which is already absorbed or which is there. So it is almost like saturated surface dry kind of condition, whereas this will have absolute dryness. So if you don't take care of this, your water cement ratio can go for a toss and you may have issues. If it is extra, then compressive strength may get affected. But if you take care, definitely you can get very good strength from the crushed stone sand made concrete or sand. So this is a test which was done long back, around 10 years back at Indian Institute of Science. You can see that between the river sand and manufactured sand, the manufactured sand slump may be slightly less, but the compressive strength and flexural strength are better than the concrete made by river sand. Bond strength was good, and it was also checked for mortar. So the workability of mortar is the most important thing here, and it should be such to allow mortar to spread easily and adhere well to the masonry units, and a flow test is good enough for you. So check the compressive strength of mortar before using, determine the water retentivity, and also, if possible, test the brick mortar bond strength. So it's preferable to test compressive strength of masonry, that is using a 5 brick high stack bond with mortar testing compression. Again, we got some tests done in Indian Institute of Science for mortar. We found that for the same flow, water requirement was more in case of river sand. Compressive strength of mortar for the same flow was more in case of manufactured sand, and water retentivity of mortar was higher in case of manufactured sand. And the case of manufactured sand or CSS, both brick mortar bond strength as well as compressive strength of mortar were greater. So quite some detail is available in tech mailer, which is produced by UltraTech on manufactured sand. You can go through that for more details. There is also talk of steel slag as aggregate. Steel slag is an industrial byproduct obtained from steel manufacturing industry, which is a non-metallic ceramic material formed from the reaction of flux like calcium oxide with the inorganic non-metallic components in the steel scrap. So the use of steel slag reduces the need for natural rock as construction materials, and hence this is being looked at. Slag sand is now being popularized. As was mentioned, this is the process of the production of the slag, and from the slag, the granulation, the granulated slag, and after grinding it, you get what is known as ground granulated blast furnace slag. So the addition of this ground granulated slag, is something which should be looked at as a replacement to sand. So this particular one is a very suitable material because it is controlled in quality in a factory atmosphere. It does not contain materials like chlorides, organic impurities, etc. Blast furnace slag, fine aggregate, does not contain materials which may affect the strength and durability of concrete. The level of compressive strength similar to that of natural sand is achieved at the material in the age of 7 days and 28 days. And it also does not generate alkali aggregate reactions. So this is, of course, the slag aggregates are available in the form of ferronickel slag, copper slag, molten trash slag, sewage sludge slag. There are so many varieties which are available, but the most popular ones are the iron and steel slag, that is the blast furnace slag and steel making slag. Of course, our code has certain restrictions mentioned on the amount of manufactured sand and crushed on, the recycled concrete aggregates that can be used. So whichever aggregate you're planning to use, what you must basically look before you choose the alternate source is to characterize the material physically and chemically, study the concrete made with that alternative materials, again in fresh state and hardened state, study the effect of long-term properties and durability, and also develop a mixed design appropriate to the alternate aggregate that you are planning to use. You may be completely changing from natural aggregates to alternate aggregates, or you may use certain percentage of the alternate aggregates. Whatever you use, for that the mixed design has to be modified many a times, and also there must be a QA/QC procedure laid down. Now, one thing that we must remember is, although there are restrictions which are mentioned, as I was mentioning in 383, for example, if you look at the fine aggregates, iron slag aggregates, only 50% you can use in plain. Steel slag you can use 25% in plain concrete, copper slag 40%, and recycled concrete aggregate you can use 25% in plain concrete. Whereas in reinforced concrete, You can use iron slag 25%. Steel slag right now is not permitted. Copper slag 35%. And if your concrete is less than 20 MPa, then you can use 20%. Up to 25 M25, you can use 20% of recycled concrete aggregate. And if you are using a lean concrete, you can use iron slag, the steel slag, as well as recycled concrete aggregate, 100% replacement. The idea is we are using virgin material for a very unimportant thing like lean concrete and plain concretes, which are not having any reinforcement and things like that. We might as well replace it with all these alternative materials and save that much of the virgin aggregates. So that should be the aim. Where it is not required, we are unnecessarily using extremely good materials and we are wasting it. It is like for dumping, for filling of the areas where you want to do filling for the leveling purpose. You need not use extremely good river sand. You can use all these alternate materials. So you can save huge amount of materials, virgin materials in the construction industry if you just think as to how it should be replaced. So in any given structure, of course, the rule according to 383 is that only one type of manufactured coarse aggregate and one type of manufactured fine aggregate can be used. So people have tried to use concrete, aggregates, fine aggregates and coarse aggregates made from bottom ash. That is, in thermal power plants, after the burning of coal, you get bottom ash as well as fly ash. So people have tried using this and they have done the characterization of the natural sand and as received bottom ash, which you can see here. So some studies were also done in checking whether pond ash can be used for as alternate for sand. And as you all know, pond ash is basically a mixture of coarse fly ash and bottom ash mixed with water and put into a pond outside all these thermal power plants. Several million tons of pond ash are being produced now. So, but all of these need to be assessed physically, and the physical characterization becomes very important to see whether there are any undue or unnecessary things that are there in the pond ash. Now, sorry. Chemical characterization of pond ash indicated that there is no variation between chemical constituents of pond ash and fly ash because basically it is the same material. So pond ash samples, they conform to the grades zone 4 of 383. At that time it was IAstructE 1970, which was being used. So there is a possibility of some pozzolanic activity, and studies were conducted with pond ash as a part replacement to sand. In fresh state, it indicated that good workable concrete can be obtained. Presence of a large number of spherical particles in pond ash in improving workability. Addition of superplastizers was warranted sometimes, when the workability was slightly less. Now, in the hardened state, density was found to be slightly less. Increasing strength at later stage was higher than the concrete with pond ash compared to normal concrete. And flexural and split tensile strength of densely packed pond ash concrete was found to be equal to that of normal concrete. So, pond ash as a sole aggregate was also tried, and up to M25-30 easily we could make concrete with only pond ash as the aggregate, fine aggregate. The problem with pond ash we found was that particles between 4.75 and say 1.18 are very, very less. Majority of it is less than 1.18. But by using particle packing theories and modifying the coarse aggregate fine aggregate ratio, we could achieve and get concrete of M25, 30, 35. People have tried using marine sand. Of course, there are concerns about corrosion and destruction of concrete structure, but the salt, in fact, remains on the surface of the sand grain only, which can be easily removed by rinsing with fresh water. In Japan, they found that about 0.5 cubic meter of water is required per cubic meter of sand to make the standards of, to meet the standards of salt content in sand. So what people have tried to do, even in Kerala, they have tried to do this, is to excavate sand. I don't know if you, see, this sea level was much behind or much lower several million years ago. So the rivers were flowing to a larger distance into the area which is right now occupied by the sea, which means the river bed is there under the sand of the sea in those coastal areas. People are planning to excavate that particular sand, which is about 5 to 10 meters below the existing sand bed of the sea, and use that particular sand, which is having same gradation as the river sand, because those were original river beds. Only problem is salt that can be washed. Now, how do they wash? You may think that a lot of water is wasted in washing. The water which is just before the backwaters, which is spent, which is just about to join the sea, that is actually fresh water. So you need to shift the sand about half a kilometer or 1 kilometer inland, wash that sand with the water which is anyway going to join the river, join the sea, and use the sand. So this is something that people are looking at. So the fineness is taken care because of the dredging or the digging that they are doing below the existing level, but also you can use partially by using the sand mixing with the natural river sand. So the marine sand has greater roundness compared to river sand, which is a desirable property. So in conclusion, I would like to say that construction industry has a large role to play in sustainable development. The drive towards sustainable construction is achievable only when all the stakeholders in the industry, including developers, designers, builders, suppliers, specifiers, owners, all of them appreciate the importance. Concrete being the most ubiquitous construction material, it is necessary to make it as sustainable as possible. Use of alternative aggregates is one of the important rules to achieve the sustainability in construction, and governments are already pushing for this, and other stakeholders have come forward and they have to make this successful. Here is a paper cutting of PWD Chennai, circular lays down the quality checks before application of M-sand. Of course, here M-sand, they mean crushed stone sand, which you can see in the first paragraph. So thank you very much for your patient listening. If there are any questions, you can put it in the chat.
Thank you, sir, for a wonderful presentation on sharing your information and experience, sustainability of aggregates and construction. That is especially with crushed sand, M sand, steel slag, and the washing of marine sand. So now the floor is open for discussion. Participants can unmute themselves and they can ask questions.
I can see
Yes.
one hand, Jan Soni. Yeah, you can unmute.
Yes, Jane Soni can.
Good afternoon, sir.
Unmute.
Sir, my question is, there is a huge difference between manufactured sand and crushed sand if you compare from the properties point of view. If we see IS 383, the provisions to use AM sand is totally different and crushed sand is totally different. But right now, 90% of the sellers in the market are selling crushed sand in the name of manufactured sand. So, wouldn't it create a problem in the construction industry, or aren't there any norms to check who is selling manufactured sand and who is selling crushed sand?
Yes, as was clearly mentioned, the one what they are selling as manufactured sand is crushed stone sand, So please check its properties as per what is expected out of crushed stone sand. Although they call it as manufactured sand. Please remember, manufactured sand is presently only slag sand, nothing else, because that's the only one which is available in the market, and only slag sand is manufactured sand. Of course, recycled concrete aggregate or fine aggregate made out of recycled concrete or demolition waste is also under manufactured sand. Otherwise, everything that they sell right now as manufactured sand is CSS as per IS 383-2016.
But sir, isn't it also an unsustainable solution? Like we are again digging up the natural resources and crushing them to use that as a sand. We shifted to crushed sand so that it can be manufactured sand so that it can be a sustainable solution. But crushed sand doesn't seem to be a sustainable solution. And it again involves quarrying of natural materials.
I agree. The alternate that is there as crushed stone sand is right now essential because the virgin sand is just not available. That is one thing. Second thing is that the quarrying of the virgin sand is creating issues on the environment. So, which is the lesser of the devils is what has to be seen. And crushed stone sand from that point of view, if they say don't use, then if you don't have permission to use river sand, what will you use? Can you stop development? You can't. So the next best alternative is crushed stone sand, which also takes care of disposal of finers or fine material, which is now coming out of a lot of quarries and is being dumped or being sold as manufactured sand.
Sir, I have a question, Francis.
Yeah.
Hello,
Yeah.
sir.
Yeah, Francis.
Yes, sir. Sir, actually, about 1.86 million housing units being constructed approximately here in India. What we are talking about in the concrete replacement of fine aggregate. But equally or even more, the fine aggregate being used in other applications in the construction. So, being a common man, residential building constructing engineer. So, what is your recommendation to use alternate fine aggregate, particularly slag sand, to mortar and other applications other than the concrete also?
See, any crushed stone sand is ideal to be used for all applications. I also said as a filling material, backfilling material, and in plain concretes where strength is not an issue. We are wasting virgin river sand unnecessarily. But all that can be replaced by crushed stone sand, and in certain applications we can use even crushed dust, pressure dust. No harm in using that. People are using golden material called river sand for all these unnecessary things. That is why two major consumptions where engineers are involved is in concrete and is in plaster. Both of them use heavy amount of sand, where we have right now discussed about using alternative materials, especially stone sand, and available slag sand. Slag sand is not available throughout the country, whereas crushed stone sand is available throughout the country.
Sir, Vishwanath here.
Yes, Vishwanath.
Sir, I have one request through this webinar. Maybe many people who are producing slag are there. We tried using slag sand, especially for plastering, but whether it is crushed sand, whether it is dust or this slag sand, what is inhibiting the industry from using it is the exorbitant price. I mean, economically, any day, anytime, backfilling with soil is much cheaper than CRS, and slag sand also is probably double the amount. It's around 1,800 to 2,000 rupees per metric ton. So this is one challenge which is faced by the industry. I think That is the major roadblock.
I agree. When Francis asked about other, other applications, I deliberately did not use the word slag sand there because I know that slag sand will be costly for backfilling and such other unimportant works. So slag sand presently can be used as replacement to the concrete and mortar sands, subject to the limitations that are there in the codes of practice. That also has to be kept in mind. So you can't replace 100%. So let us say slag sand costs a little extra, but you are not replacing the entire sand. You are replacing 20% or whatever. So the 20% of that increased rate will come into picture. So if it makes commercial and technical sense only, anybody will use it. So it happens to be costly because steel manufacturing, that is the price that they have fixed. Now, crushed stone sand, again, between unscrupulous manufacturers and good manufacturers, there is a rate. So rate differences will exist compared to river sand. Now, today, river sand is not cheap anymore. It is also damn costly. So that way, there are applications where you use crushed stone, that is quarry dust kind of material which can be used for backfilling, judicial mixed with soil.
Sir, Kalgal sir, Jaishankar, one point I want to add here is that many places where we go there, one question is always asked is how to differentiate between this or the crushed stone sand as well as the dust, what you get. So basically what we are doing is many of the cement manufacturers has got mobile lab, concrete labs, which has got the sieve sets. Two things what we are checking is one is in the 2.38 mm sieve, sieve it and see the particle size, how it is looks, whether it is cubical or needle shape. And easily we can identify it's a good manufactured sand coming from a source. Second thing what we are doing is going above the 150 micron sieve, what is that passing through? If it is very more, then we can understand the sand is either from the dust or it is the manufactured plant also if it is not washed properly. So these are the two things which we can easily identify a good manufactured sand. And since most of the cement companies have got mobile concrete lab, has got sieve sets, the customer can easily use this and we can identify whether it is really a good manufactured sand or a dust.
Yeah, I agree. For an individual house builder, he may not have any equipments to measure or to check the sand. So a mobile lab or something, which gives this facility will be useful. One is the gradation by sieve set. The second one is a simple beaker to check the silt content. These two will be something which the mobile labs can give. But what he can also do is what I said, take a photograph from his mobile phone, zoom it and see for himself how the particle looks like. Is it cubical or is it flaky? So that also gives.
So
and anything which is above 75, passing 75 micron, people have to be very careful. If it is of higher magnitude, more than 15%, it is likely to create issues in the concrete or in the mortar, like shrinkage, cracks, etc., etc.
Hello.
Yeah, we can hear you.
Hello. So that's the shape that the fineless model is more than the 3.54 like that is coming, sir, gradation. And some of the time the our silk content is more than our IS386. In this time, what will we do, sir?
If it doesn't pass the codal requirements, it doesn't pass. The decision is yours whether you want to stick to the code or you don't want to stick to the code.
No, I want to stick to the code, sir.
Then reject the sample, no?
Sir, most of the quarry I visited, sir, everywhere the is not passing the code, sir, as per IS383, sir. For plastic purpose, is not passed, sir, but MSAT is maybe passed, sir.
Okay, I don't know about your geography, but in Bangalore, there are people who will give you as per the code. So there are some manufacturers who are standard manufacturers who do give Anybody who claims he is giving CSS, he is not giving CSS. He must have a separation facility, washing facility. If he doesn't have, then it will be a problem. So we can't help it unless it becomes mandatory. And if nobody buys from him, then he will fall in line. Okay, done.
Yes, sir. Thank you, sir.
Thank you.
Further, from the participant side, I request Dr.Surender Singh, if it's possible, we can upload this recorded video in our website.
Yeah, sure.
After the due permission from the EC members, it will benefit for the participants. We can add it in digital resources also.
Yeah.
And then for the participants, we have posted the feedback link in the chat box. Kindly fill up the link so that we will be able to give you certificates within a couple of days. Further, a formal voter thanks from my side. Good afternoon to one and all. It is a great honor and privilege to propose a vote of thanks on this memorable occasion. First and foremost, I express my gratitude and thank all our invited speakers, Dr. Manamohan Kalgal, Dr. Surender Singh, Mr. Ram, and Mr. Prajapati, who despite their busy schedule has found time to grace this occasion by delivering a wonderful lecture. Lectures gave deep insights into the topic of construction and demolition waste and revealing some interesting facts. I must mention a deep sense of appreciation for Dr. Surender Singh in arranging the webinar and sharing the scenario of C&D waste in India and abroad and processing the C&D aggregates. Further, we are grateful to Dr. Manamohan Kalgal for sharing the valuable information on experience in the sustainability of aggregates in construction. I like to express my sincere thanks to Mr. Ram and Mohan Prajapati for sharing information about process, policies, training schemes, research and developments in demolition waste and handling practices, and also the beneficiation techniques for RCA and case studies in the IIT Madras. I like to thank the Indian Concrete Institute, Chennai Center, and Department of Civil Engineering, IIT Madras, for arranging this informative webinar. It is my wish to convey my sincere thanks to Dr. Manu Santhanam and Dr. Radhakrishna G. Pillai for support in their program. Nothing can be achieved alone and function like this wouldn't have happened without the effort and support from the sponsors. We are really grateful as well obliged to thank the sponsors, UltraTech Cement Ltd, for extending their support in the form of sponsorship. A big thank to all the members who have supported and sponsored the program. Last but not least, I extend my heartfelt thanks to Ms. Ramya from ICI Chennai Center for hard work in conducting this webinar and making this event a great success. Also, I thank all the members who have participated overwhelmingly and making this webinar even full. If anybody's name is left out, who have worked directly or indirectly for the conduct of the program, it is unintentional. Thank you. Thank you from my side.
Thank you, Dr. Kannan. Thank you, Kalgal sir, for sparing some time in sharing your experience. In fact, I also learned many things from your presentation. So thank you once again.
Your presentation was also wonderful. I mean, like I miss the academic, flavor. So it's good to hear people who do a thorough job. Good luck to you. Good luck to you.
So Surendra Singh ji, one Jaishankar here. Actually, we did this construction and demolition waste with Professor Satyanarayana. Ram was one of the presentation. This thing, a lot of work has been done, and we call all the corporation key persons for that this thing which was done at IIT Madras. So I am really happy to see that at least 2 plants are now coming, which would have come long back in Chennai.
No, unless
I think we should take it.
Government is making it mandatory in some major projects. Probably that is the only way people will start getting accustomed to using. Otherwise, they want someone else to fall into the well and then they can find out what is the depth of the well. Nobody wants to try. So everybody says, let others do it. So now
at that time, actually, a detailed book was presented to Chennai Corporation by IIT Madras, taking care of how much waste is generated and all the things. They have identified some place for the plant also at that time.
Chennai Corporation is very, very progressive that way.
Yeah,
Very
but it
but it's
took a
not
long
true
time to come for the
not
planned. No,
not true pan India. Very difficult to push this concept. From those two plants in Rohini, Delhi, it has taken how many years now to come to this stage, of even a few more coming up. It is so difficult. Yeah.
so I think we
Chalo,
should
okay.
drive ICI as well as IIT Madras and all the stakeholders
Yes,
should
yes.
drive it.
ICI should push in a big way. ICI should push in a big way, along with IITs. Okay, thank you.
Thank you. Thank you.
Okay, thank you,
everyone
sir.
for-
Bye.
I hope the participants will be joining for next month webinar also. So maybe you can visit our ICI site and then you can see we'll be having different dedicated programs okay, on the similar grounds. Again, I would like to say thank you to everyone, the organizers and the participants and the speakers. Thank you.